Hi everyone, thanks for coming today. My name's Laura Knight. We've got a webinar for you today on cloud computing. I'm just going to hand over to our academic, Justin Champion.
Hello, how are you doing? So, welcome. Thank you for coming to listen to this talk. I thought, introduce something in technology you've probably heard of quite regularly from us, and I want to give an idea of why cloud computing has become as popular as it is in the enterprise. Give you some sort of overview of where this is actually coming from, what that driving force is behind it. And again, it's just a short introduction into this. Myself, just to put a picture on there for us, you can see what it looked like. It always quite nice to put a face to the name from us. My name is Dr. Justin Champion. I'm part of the cloud computing group at Staffordshire University from us. So I'm part of the research group. So we're involved with PhD and Masters by Research within this particular field because it's so important. I'm also one of the people who is the trainer or instructors for Amazon Web Services. Amazon Web Services is the largest of the cloud computing providers at this particular moment in time for us. And we teach to undergraduate students, we teach to postgraduate students, and we qualify for teacher areas. So practitioner, architecture, design infrastructure, systems operations, DevOps, machine learning, and data analytics, important aspects of the cloud computing and areas which really we need people to know the most about, where it's developing at the quickest rates for us and where people actually require the skill set from it. So like today, let's just have a quick look, an overview of this, trying to do some of the technology for you to see this. So that term cloud computing, it's a term which is everywhere, realistically. You hear it on a continuous basis. You've seen that store your files in the cloud, stream the music from the cloud. You see things like Netflix, which are operating out the cloud, and Netflix is actually running 100% on AWS infrastructure, which is a public cloud provider from us. And it's one of those terms which we just sort of accepted realistically, that we'll just run and do something in the cloud without really thinking about what's going on within the background of it and understanding why have we got to this point so quickly where we're now running most things out of the cloud. In lots of areas now, the majority of it is actually running out of cloud infrastructures. In a lot of cases, people shouldn't be able to realize they're running out of the cloud from us. That's part of what we're doing, basically, moving away. But again, let's see the ideas of this. Let's see where the concept's coming from, why all of a sudden we're trusting everything into these cloud providers, what are they giving to us. So we'll have a look at these. I've tried to give these as sort of the major breakdowns, these additional consideration from it, but the sort of major points that we'll cover on this lecture is cost, which immediately for people in the industry, business people, that's always a consideration. It's much more than just cost reductions, it's far more than that. It's also looking at things like increased reliability from us, flexibility, giving us the ability to try technologies out quite quickly, security, increasing in the security we actually have in there from us. And I suppose this is the fifth point, depending on what organisation you work for. It's also the global reach, where your organisation might be today just operating, let's say, in the Staffordshire area or the West Midlands, but actually in the near future, you want to be able to roll this company out and do stuff now, which is in Asia, let's say, or you want to move to the United States and run it. And again, without a lot of changes, once we're in the cloud environment, it's actually quite straightforward to move that and your data centers out on a global basis for us. So it's important, like I said, technology from us. But let's have a look and give some thought to where we're actually coming from. So what are we starting to replace, or the thought process from this? To start with, I've got your diagram here of some generic data center from us, but we've got those considerations. You'll have data you've got to store, you need data you'll need to process, whether those are databases, whether they're servers. There'll be something physical which you will actually own from us. The problem with the physical is number of points. It's expensive to purchase. There's that initial thing there of the capital expenditure. If I want to purchase something, I need that money up front from us. But what do I purchase? Again, we're sort of guessing at this. Again, you don't need to, whether you're dealing with data centers on a daily basis and large databases, it doesn't matter. Just think about the laptop or computer you're sitting in front of right now from us. And I'm certainly sitting in front of a laptop now. I purchased a laptop. It was purchased last year, this particular one from us. It was purchased with 16 gigabytes of RAM and i7 processor. That's the point I decided that actually this is beyond the specification of what I require to do the work that I actually do from us. So I'm having to sort of forecast and guess what that peak's going to be. Now, what happens if I now need more RAM? All of a sudden I realise I'm not actually doing what I was originally thinking of doing with this. I want to do something different. I've figured out a different way of doing things, which requires, I want to run, I don't know, large scale simulations, let's say a network simulations inside here. I need more than 16 gigabytes of RAM. On this device, as in lots of them these days, the way they've actually gone from us, I simply throw it in the bin. It's no use to me any longer. I now need to have the capital expenditure again to go and purchase another laptop now, which has got far more computing power from us, basically. So we've got to think about those. If I'm purchasing as well at the, what I believe to be the theoretical peak, so we take that to 32 gigabytes, what happens if it changes? So again, I've made an example here where I said, well, actually, I now need to have more RAM available to me or more CPU time. Could be storage, it doesn't make a difference what we actually choose in the cloud environments. But I can then downgrade. So at which point I realized, well, actually I bought 16 gig of RAM. I didn't require that. I probably overspecified. Again, in the physical world, that's a bad luck situation. We've purchased it, we've got it there, and hopefully at some later stage, we'll justify the expense we've actually got from it. But also things like this data centers as well. We need to think about your physical security. Again, don't think of them as data centers, think of your laptop. What have you got to secure that down, stop people stealing it? We need the staff on site who know how to deal with this and make the software and hardware actually operate from us correctly. We need physical space to put it. It's all these sort of considerations that we need to give to us for us. And hopefully we're part of a business which is expanding and growing all the time for us. So those changes will be happening on a continuous basis. And so we see at this moment sort of physical or infrastructure from it. So what's changing? That's, I guess, the thing we need to start thinking about. What's going on now where we're starting thinking about cloud computing? Okay, cloud computing, this data center here, which you see on the left-hand side here, has not changed. All that's changed is now it is being run and controlled by cloud provider, whether that's AWS, Amazon Web Services, whether that's Microsoft Azure or Google Cloud. Probably they're the big three, which probably most people will have heard of and maybe actually dealing with at this moment in time. We want to stop thinking of hardware being hardware. What we want to do, which is what the cloud providers do for us, is start thinking this as being software. Start thinking about what you actually require, not being restricted by the physical that you need at this moment in time. I need 5 terabytes of storage. Okay, then we need to purchase 5 terabytes of storage in the physical world. If we move to the cloud world, that is there already for us. We are simply going to pay for that 5 terabytes of storage, and we request it as a piece of software, exactly the same. So we compile and change the code, exactly the same inside our cloud infrastructure. It makes it very quick to do anything and very quick to actually adapt to whatever our individual requirements are for us. And that's what we want to start getting to. We want to start moving away from the idea of being restricted in what you can actually do into moving into a concept where really we want to be the restriction, it's just our imagination. And we'll see that coming through later on. What our company decides to make money on should not be restricted by the physical hardware or the staffing skills you actually got inside your organization. It should be restricted to just where what you actually need to make the money from it. So I'm going to give a different consideration from this, and it's the same thoughts. One of the things you see continuously for cloud computing is they refer to it as utility computing, which is actually quite a nice way of thinking about it. Try to give the idea from these ones. So you could, inside your organization, generate your own electricity. Based on today's newspapers, it might be a good idea, but that's our thought process. We might be able to generate our own electricity. But is that realistic? It's expensive because you're the only person using it. You've then got all the reliability considerations. You've got the scalability considerations saying, right, today I need to generate 2 kilowatts. Tomorrow I need 5 kilowatts of electricity. You need to meet the legislation and compliance. Okay, we don't generate our own electricity. Most companies don't. Kodak was an example did a few years ago. It doesn't make sense. It makes sense to move that to some central location who will generate the electricity for us, and then we'll purchase it them off them. Cloud computing is the same. You're not generating electricity. What you do is you plug your computer into a plug socket on your wall, and then at which point you turn the power on. The power flows through. You pay for the power you're actually using. When you're finished, we turn that power back off again. Cloud computing is exactly the same concept from this. They are dealing with all of our infrastructure that we actually require from us. It's them who are dealing with the responsibility of keeping that actually operational. What you do is simply request that particular thing you're after. So I'm concentrating on compute power at this moment in time, but that could be lots of different things. Cloud computing supports a lot of things from us. When you finish with whatever you're using, you simply terminate it, stop it, and stop paying. So again, we can move into a more flexible approach inside your company. I need a really powerful server to carry out some calculations on some work, but I only need it for the last Friday of every single month. I need to have this to get the results ready to be presented on the following Monday. Well, in the cloud computing world, we don't need to have that computer sitting there for the entire month waiting. We can use that computer, we can carry out the calculations just on that Friday. At the end of the Friday, when the calculations are finished, we automate the process, we'll shut that down, and then at which point we'll stop paying. Exactly the same as you're doing with your electricity. That's why the term utility computing is used quite regularly. It's a nice way of trying to think about this. So I've got an example for you where you can see this actually operating from us. I'll try and get you a copy of these slides afterwards once the lecture is actually finished from us. There's a nice example here for this gentleman. This gentleman was part of the project. He was an expert in supercomputing, or is an expert, sorry, in supercomputing. And they had a particular problem. If I remember correctly, if you click on the link, it'll bring it up for us. They were looking at a medical problem. They realized to solve this, they would need access to supercomputing power. Instead of setting up a large supercomputer or actually borrowing one, what they did is they set up this inside public cloud. Now, in this particular case, they actually use AWS, which doesn't matter whether they use Azure or Google. The process is exactly the same. So they created their supercomputer. It cost them $5,000 US to set this computer up. They carried out all the work they've done. They shut it back down again. The total bill was, like I said, it was just slightly over 5,000 for the total bill for us. While this supercomputer was running, it was actually 136 in the top 500 supercomputers. So we're starting to see there flexibility. He had a problem to solve, but didn't want to deal with the hardware. Therefore, he borrowed it from a cloud provider. Nice thing about this particular project is that, like I said, the gentleman and the rest of his team were experts in supercomputing already and already come from different projects, and they were able to actually give a number to this. So equivalent compute power would have cost them between 20 to 30 million US dollars. It would also have had a build time of 6 to 12 months, and afterwards they would need to find something to do with the hardware. 20 to 30 million dollars actually cost them 5,000 US dollars because of that flexibility that they could actually use there. And when they finished, which would go on a normal corporate credit card, they simply shut it back down. There was nothing special, which is the thing I want to stress on this. There was nothing special about this project. Simply used AWS as an engine from us. They did not inform AWS before they started the project. They didn't have any special permission. They did not have any support from the cloud provider. It was a great demonstration of how the public cloud could be used. Once it's finished, shut it back down, all the bills, and hopefully whatever he made in terms of being paid for that particular project, hopefully cost considerably more than 5,000 US dollars. The rest of it was the profit for them. So there's a nice example of speed and flexibility which comes out of cloud computing. We've also in this country, for us, I've taken this quote from the Majesty's government. This is a quote taken. Again, I've given you the link so you can have a look at these later on from us. The UK government now has a cloud first policy. I've taken this just as a quote directly from them. Basically, anything which is used in Majesty's government, any of the departments, now have a cloud first policy. Evaluating potential cloud services before you consider any alternatives, which is Crown hosting, which is their own private data center. So they're pushing it, and you can see this continuously. If you're looking in the register, you look in the newspapers, you can see many government departments are transitioning everything across into cloud computing now from us, basically. The point from here is probably the one at the bottom, which I thought was quite nice. Alternative provider must also show you've allowed for flexibility. So we're not stuck, back to the beginning, where I said at the beginning, we're not stuck in one idea. Our environment is flexible, it changes and grows. We've got examples of that coming through as well in a moment. And reduce the costs over time. That must be demonstrable. But again, it's what cloud computing does: either reduce the costs or increase the performance at the same costs at this particular moment in time. So it is UK government policy from us, and it's not UK government. We've got examples later on. It's on a global basis now, the transitioning across to using these environments. So cost is the one which gets the most attention. I will accept that entirely from us, but like I said, cloud computing is far more than simply the cost. But I thought I'd give this as an example of flexibility and costs. Right, nothing which is made available in the cloud which is only useful for one group. So what I mean by that is that there's nothing here which is actually private. If a technology is added to the cloud environment, it is a technology which is added and everyone can actually make use of. It's not a case that Her Majesty's government for the UK insists on a particular type of database engine, let's say that as a target, or machine learning engine. That is made available so everyone can actually use it. It levels the playing field between companies. The idea is you concentrate on making money. You're not having to worry about what can physically be available to us. So I've got a really good idea, but I can't do anything with that idea because I'm afraid the company at this minute doesn't have the money. I'll give this example, again down the bottom, get the point across. You've decided using AI, machine learning, that you could extract some meaning from some data that you've actually got, and you can then realize, actually, if we can do this, we can make a lot of money out of this. So a lot of the AI engines do require graphics cards. So I put in here the NVIDIA Tensor Core cards. If you can buy them, and it is a question at this particular moment in time whether you can buy them because they're highly unavailable to what's going on in the world at the minute with chip shortage for us, they're about £5,000 each to purchase that. So in my case, I've got 4 of these I want to make use of, test an idea out inside our physical environment, which I've got there from us. So there's £20,000 before the server, before the power, before everything else needs to come with it. If your idea works out great, fantastic. If the idea works out really badly, then we need to find somewhere to get rid of those Tensor Core cards. Actually, in this day and age, with what's going on with graphics cards, you should be able to probably eBay them for probably similar to what you've actually paid, but that's because we're in a quite strange environment at this particular moment in time towards computing. But let's say you want to try this idea out to make yourself some money, and we want to try it in the cloud. In the cloud, 4 of these cards will cost you $14.35 in the what's referred to in AWS London region. So in other words, in the UK for us, basically, they refer to it as the London region. You can borrow that, and that's per hour. You can borrow it for 5 or 6 hours. When you're finished after 5 or 6 hours, simply shut it down. If it made you money, then at which point we could look at that using them again to make money again from it. If it didn't, we shut it down. We'll stop paying at that stage, and we can move off now and look at something sort of different and adjust our ideas. So if we want to move away from the idea, restrict it to what money you've got to spend and the physical hardware or the skill set you've actually got inside your organization from it. Now, one of the things we can do inside cloud environments, which is a lot harder to do inside of the physical environment, beyond simply borrowing this, we've decided that I really like the idea, but I'm not willing to pay $14.35 to test this. We can also use what's referred to as spot instances. Now, inside an AWS data center, same with all the other cloud providers, they will have hardware which is sitting there waiting to be used. If it's being used, then it's making AWS money. If it's not being used, same as any other business, it is costing them money. It is devaluing from it. So what they do is they introduce a technology called spot instances. Now, spot instances allow you to bid and use spare resources inside AWS from it. So if it's not being used by anyone else, you can bid to use. Because you're bidding on spare resources, it is much cheaper. So I've got this thing here, I pulled these numbers off yesterday for us, $14.35 to guarantee to be able to use those NVIDIA cards, 4 of them. If you're willing to use spot instances, at which point the price drops down to $4.30. And just as, for people, everything in cloud world is paid in US dollars. It is not paid in local, no, it's paid in local currency, but pricing is always given in US dollars, no matter where you are in the world from us, basically. Disadvantage with spot is it may not be there. So you might need it now at 2 o'clock this afternoon. It might be that they have no spare resources, therefore they can't give you a spot instance and you have to pay for this. But as long as you're a little bit more flexible And when we're trying out ideas, which is the example we saw previously, we can be much more flexible in our usage and say, well, actually, I don't need it today, but I need to test this idea out the next 5 days. Then we can request spot instances. So the chances are within the next 5 days, there will be an available time period where we can actually use it. You can see there, it's over $10.05 cheaper per hour. So it's perfect for, back to here, experiment you wanted to do. Once you know that it's always going to work and you need to guarantee that it always runs at 5 o'clock every Thursday, let's say, which point we'll pay more, but this one we're guaranteed it's actually going to be available for us. So different considerations, different ways of seeing computing, moving away from this idea of physical away to this virtual where we pay as we use and we benefit from that and benefit inside our organisations. Lots of very large organisations are based on spot instances. So an example which I haven't put into the slide, NASA. Awful lot of work which is done by NASA, their space exploration, the compute work they do are done on spot instances to try and reduce their costs quite considerably from where they would naturally be, basically from that compute power they need from it. So let's move forward again. Because again, the ideas from this of trying to figure out what's successful ideas and otherwise from us. Here we have our capacity. Again, I've concentrated on compute. It doesn't matter whether that's databases, whether it's storage, whatever it actually is you need capacity for. We can see here that we forecast our growth is going to be here, this grey line. We need to buy the hardware physically to actually meet that, which is what this green line is actually going to be. So in this particular case, where my mouse is now, the light green, this is where the blue line's telling us what we actually demand for us. The green line is costing you money as a business because you're over capacity. You're wasting money. You've paid for more compute power in the case of this particular example, doesn't matter different storage or anything, than you actually need. So you're wasting money. Here, where it goes grey, you've actually ended up below where your actual usage actually is. Therefore, your customers are receiving a bad experience. Now, in the viewpoint of cloud, customer is not just someone who's coming in from the external to your company. Customer might be your internal employees who are trying to access the database. It's anyone who's using that cloud environment we consider to be a customer. So here, the database, we'll say that's a target, appears to be running really slowly. And here again, it's now running really quickly, but it's so quick that actually we're wasting money. We don't need to spend that amount of money for it. And that's going to always be a problem when it comes to physical. Once you move to the cloud environment, I've stressed on here correctly configured. In lots of cases, the environment will grow based on whatever is important to you. So here we can see our yellow line, first orange line, and that's growing. And more importantly, shrinking. You notice here, we've got a reduction in demand. This might be 10 o'clock at night. This could be for a single day. 10 o'clock at night, we have no customers using our systems. Therefore, I want to shrink that back down and save money until the next time we get a large amount of people coming in to actually make use of it. So again, it's growing with us, and it depends on what we're interested in. Of course, here we've got the word compute. It doesn't have to be compute. It can be absolutely anything at all. We can scale and build based on that particular thing from us. So we only use the right amount of compute power at the right time, and it's growing with us. Automated, correctly configured, no human beings involved in it. We want to make sure the full system is fully automated from it. So again, let's deal with one of the other issues, security of the cloud. So one of the problems which comes with cloud computing, at least from the picture of them, is that cloud computing is connected to the internet. The internet is the Wild West. We've got security issues. People are hacking into the internet continuously, which we see in the newspapers. Therefore, by its very nature, cloud computing must be insecure. Well, across one point for us, the cloud computing does not need to be connected to the internet. There's lots of other ways of actually doing it. Staffordshire University has a different way of connecting in, so we can do private links. But if we ignore that concept, we have two considerations: security of the cloud, security in the cloud. We need to give some thought, skip forward, to those sort of thought process from us. Security of the cloud is what you're paying the public cloud provider to do. So in our case, I'm going to say concentrate on AWS from us, referred to as foundational services from it. So they are keeping the data center with enough electricity. They're keeping enough power in there. They're keeping the cooling correct so everything considered works. They are physically protecting their infrastructure certified external level from us. If there's attacks taking place where they're trying to consume all the resources in the network, AWS will actually sort those out, same as Google and Azure will. Security encryption keys, if you decide to entrust those into their infrastructure, again, those are externally certified to make sure they are actually completely secure. Also, none of the employees inside the provider, so in our case AWS, have any insight to your instances. So just because you're using a compute server inside of AWS, no one inside AWS can actually see what you're actually doing on that compute. All they know is you've got a compute server is from us. It's all to do with security, so no one has access to what you're actually doing inside there. Everything's heavily encrypted. Security in the cloud, that's off the cloud. In the cloud is your responsibility. So it's things which you are doing, and it's no different, same policies you run in your company. So a cloud server, you're deciding who has access, who has read and write access, what software can we use inside that server for us, how often do we change the passwords, how do we authenticate that the passwords are absolutely correct. All of that is then down to your responsibility from us, basically. A lot of additional options, though, are provided for you completely for free. They're not charging, so things like I am free, logging and everything, what's taking place, the cloud providers will provide you for completely free from us. Now, we do need to meet certain certifications, our compliance, and again, I've just taken these as the Europe and the global one from us. So if you're using, I've taken AWS again as their provider, you need to meet G-Cloud status. There's to get a certain contract, or you might be doing more in Europe, so we want C5 status. Because you're doing the business in Germany from us, the cloud provider already has these certifications in place to indicate that these are actually secure from us, basically. And at which point, your policy sits over the top of them. So they are, all the cloud providers are independently security audited, realistically, from us. It's not a case of, oh, you need to go and defend it. Those decisions are already made. So they're from the cybersecurity, the ISO 27001. Already there for you, basically, the security management and control, just simply making use of those. I thought I'd give this again just as a thought, so I don't want to push too much on it, but it's a consideration. March 21, I'll give you the link to look at. 50,000 patient records have been made public. They were stored inside AWS Cloud. This is a security problem because AWS Cloud is insecure, and S3 is just simply a way of storing information inside the cloud environment. So blog itself goes through and tells you lots of information about this. No, it wasn't. In this particular case, the company in question literally made all the information that they were storing publicly available to the internet for some reason. They also ignored all security advice. When you try and make things public on S3, it will give you lots of error messages. It gives you lots of warnings saying, do not do this. The consequences will be the following, and it's quite easy to read. Ignored all of it. Where it turned out, if you read the blog, it turned out the person who was actually setting this up had never done any cloud training, never done anything in this environment, and has simply decided to ignore everything and make it available. And unfortunately, 50,000 people's records were made public. But again, it was because they didn't understand what they're actually doing. And in the blog, it actually does tell you there, the person themselves gets across that they didn't really understand what they're doing. I thought I'd give this example, though. Again, you're thinking about security, thinking about your considerations from it. I don't think you can get a better example than this. The CIA, which is the Central Intelligence Agency, the American Intelligence Agency, the videos there's lots of them. The Central Intelligence Agency, CIA, transitioned almost all their data across to, in this case, it was actually AWS, but Azure's got some of the contracts as well, from us into the cloud. The Deputy Digital Director is there. There's lots of the talks on YouTube. It's simply because they said it was a more secure environment to use. Obviously, they have the right people who can make these environments completely secure from it. And also, they like the fact that they can scale up extremely quickly. They might have an incident that requires large amounts of compute power very quickly to actually evaluate all the information. And that's why they said they put it all into the cloud, because they've got access to secure environments that they can make available to lots of their different departments all around the globe. And they can scale up quickly to look at particular issues, image processing, whatever those will be, data mining sort of techniques. So the CIA is an example. I can't think of a better example. They're storing all the information into the cloud, so it gets across. It is a reasonably secure environment for you to make use of. One of the other things we're sort of interested in now, continuously coming up, is things like green computing, our carbon footprint that we're being told about continuously. Cloud computing, I put the links on there, is seen as a green solution to the IT problems. So why is that? Because ultimately they will be drawing many, many kilowatts of electricity into their centres from us. But the idea is they use a lot less power than potentially somebody else will actually do, who's running it across large number of businesses across the UK from it, basically. You can also locate their data centres in terms of the best place in terms of the environment. So if I've got a company in Stoke-on-Trent, the likelihood is my data centre, give me a second. So I do apologise, is going to be in Stoke-on-Trent as well. When it comes to putting the cloud, we can locate it somewhere else within the UK, for the UK region, which is naturally, on average, I don't know, 2 to 3 degrees cooler than it is in Stoke-on-Trent. Therefore, that reduces the cooling bills immediately, because cooling is one of the big things that draws so much power for these large data centres from us. So it helps with the green computing. I've another video here, which is quite nice. This is from Microsoft Azure. What they did to deal with their cooling issues, I'll give you the video so you can look at those, is that basically they sealed all of their data centre content into a tube and sunk it off the coast of Scotland. Why? Because ultimately the cooling was then being done by the seawater. They got rid of that cooling bill entirely. The equipment doesn't need to be maintained, so the end of life or the mean time to failure was the same time, and all they did is decide what the mean time to failure would actually be, and then at which point they brought this back up from the ocean. But there you've dealt with something which nobody's going to do in, let's say, Stafford as an area from us. We're not going to suddenly decide to sink a data centre in the lake, but these companies have got the money and the resources to be able to actually do that. And it was very successful. If I remember correctly, only one server failed, if I remember correctly, from the Microsoft one for the entire time that was actually buried, which was quite a bit of time, really. So it was underwater for quite a bit of time. So very, very minimal from us, very, very successful, and an innovative idea to help with this green computing and sustainability, the carbon footprint that we're always being chased for these days. So let's give another idea. Again, I was trying to throw ideas as different things we can actually do in this environment. At the moment, we'll say that we've got a physical server. Just think of the server as just being your laptop you've actually got. Whether you use that in the cloud or you use that physically on site, you're paying for it. You're paying for that one, so it's running 24/7. It will have to be as powerful to deal with all the requests which are coming in, so it needs to be able to scale to your requirements. So very often, it's going to be doing very little because it's really powerful and it's designed for your peak requirements from it. One of the technologies which is very, very popular now inside cloud environments is referred to as serverless technology. You've probably already used this, but you probably don't realize from us. So if you use an Amazon Alexa, you've got one, certainly I have, and the only thing I ever do with it is ask it to tell me what the weather is. You're actually using Lambda technology there. Lambda is serverless technology, and Google and Azure have exactly the same technologies for their environments from us. So the idea for this is Lambda technology. It scales to what you need. So think about it. With your Alexas, I suspect on Christmas morning, everyone's buying it and they're trying to figure out what to do with it. You can have hundreds of millions of requests coming in, and it scales and continues to work with you. But then by Boxing Day, when people are bored, it's probably down to about 10 million requests again from us. But that's what it's doing. Lambda scales up. All you need to do for Lambda, you don't need to run a server. You just simply need to write your code. Write a bit of code, whatever language you like, Python, C++, C#, whatever language you like, you write the code and you load it into Lambda. There is no server to actually hack into. Security issues sort of disappear for us. It also scales to whatever your requirements are. If someone's connecting to this function to run it once every few seconds, fine. If you're getting hundreds of millions of people coming in, probably a bit extreme for us, we'd have to pay extra for that, but it will scale to those actual requirements. What you actually do inside here now, instead of paying for a server running 24/7, simply pay for the CPU time in groups of 100 milliseconds and the memory you actually require. I'll give an example here, just a worked example. If the function you've got there is called 30 million times and it takes 200 milliseconds to complete, you need 128 megabytes of RAM, it's going to cost you $11.36 to deal with 30 million requests. And BBC website is an example of that, that's using serverless technology. So they're only paying when it's being used. The idea is when it's being used is when you're making money, therefore you can make this technology from them. So again, it's a different technology which we don't see elsewhere from us, and it is very, very widely used. Serverless has become extremely popular. Lots of companies use it. I've got an example here for you to see, give an idea from it. Coca-Cola vending machines. Again, I'll give you the link so you can have a look at these ones from us. Vending machines, previously, we're using servers inside AWS environment. All they did was transition across using serverless from it. The idea was, again, the link will actually give you in there from us, didn't need to be able to work out what their capacity was going to be. They didn't need to auto scale to deal with that particular capacity, and they could deal with sudden rushes, which they can't predict. I'm guessing for a Coca-Cola vending machine, a sudden rush might be that you've got, I don't know, I'm trying to think from us, a really hot day in Stoke-on-Trent. All of a sudden, lots of people want to use the vending machine, or an event takes place in the city centre. Therefore, now lots of people using it. We don't have to worry about that. The client made the order, came through into Lambda that deals with all of the logic from it, push notifications, and then finally return back. The advantage with this moving across to serverless from Coca-Cola's viewpoint is the whole response time was much quicker. So it was quicker from going from paying to actually be able to release the can, so you can actually see the pot popping back, you can pop popping back out again, but also back to that cost thing. It reduced their cloud bill, they saying from $13,000 US, $4,500 with increased performance and much more increased number of users at any particular moment in time. Because once they realised this was quite successful, they rolled it out to lots of their Coca-Cola machines. So again, something which is different, seeing something different from what we see inside our physical world, taking account and benefiting from the cloud environment from it. Then, I'll think of an example from us, different considerations. So one of the things which we might think about is that the cloud computing environments are changing continuously. So we're sending information from my office, which is sitting here in Stoke-on-Trent, into this cloud environment, and that could be going anywhere for us. One of the things which has been introduced now is referred to as edge computing, trying to get compute work done close as possible where the original source of this. These are referred to as edge solutions from us, basically. One of them is called Outpost. There's Lambda at the edge. There's lots of the solutions. The idea is for this is to recognise that actually the internet is not quick. If we're going to send information across the internet from us, it suffers badly from delays. It suffers quite badly from things like jitter as well, so variance in its delays from us. If the closer we get to the edge to where the customers are, then at which point the more we reduce that particular work. So lots of work now is not done inside the cloud. It's done at an edge location, which is not in the cloud. Only the results of what we actually carried out will actually be transferred back into the cloud environment. So for example, someone uploads some information and they're using an American date system. We could actually adjust that to American date to a European date as an example at the edge quickly and then transfer that on. Or moving files, we can compress that file at the edge, send it then across the infrastructure, reducing our storage bill for us. So lots of information is now done at the edge for us. The thing about cloud computing is it's never changing. As back to the point I said earlier on, it's great at leveling the playing field. As companies come up with new ideas of things they want, the cloud computing providers will actually provide solutions to those particular points for us. Once we've actually got those solutions, they're available to absolutely everyone to actually use. And it's that point again, it's the one to stress. We want to get away from the idea that I've spent a lot of money. I've spent £20,000 on some graphics cards. No matter what, we're using those graphics cards. You're not stuck on old hardware because you invested money. We can use state of the art. We can change it across going, well, actually, there's a new technology that's come out now, new versions. Let us quickly change across to those ones. And it is quick. That's the thing to say here for us. Requesting things usually can happen, and certainly within 60 seconds. It's very little that actually takes longer to actually set up for us. Again, it's those instantaneous decisions. You've got the idea, you want to try it out. Let's try it. If it's successful, great. If it's not, shut it down and stop paying for us. You can really experiment. It's that point again, think about hardware now as being nothing other than software. All you need to think about is what's going to make you money. What do I actually require? Once we've got that cloud service will be there for you, ready for you to actually solve those particular problems. And all you're doing is putting your logic in it. So in other words, it's the stuff that you're doing which makes you different from your opposition company. And lots of companies you can see have already transitioned across this. So thank you very much for your time. I wanted to, like I said, give an overview really. The problems of cloud computing. There's a lot of technology to this. There's an awful lot of technology to it, but it is a technology which is being very, very widely adopted now from us. As lots of companies have moved across this one. Staffordshire University is an example, transitioned across a number of years ago to Microsoft Azure. All our physical servers we got rid of. Some of the biggest companies you might be using will also be doing things. So I always give Netflix as an example there. They didn't transition. They started off from day one doing this stuff inside of cloud environments from us, but Ticketmaster through to all the biggest companies you can think of are running these things in the cloud, and it's being done for there's some of those benefits which we've talked to today from us. So thank you very much. I want to hand over now. I'll just move forward a little bit to the next slide for us. But afterwards, if you'd like to have a chat, more than happy. I'd love to actually be able to talk to people. So that'd be fantastic. Thank you. But thank you for your time.
Thank you, Justin. That was really helpful. Hi, everyone. My name's Laura Knight. I work in the Innovation Enterprise Zone here at Staffordshire University. I just want to have a quick run through of some of the support that is available to businesses that we work on at the moment, the different projects we're working on. So at the moment, we do have some free, fully funded courses for Staffordshire-based SMEs, including Amazon Web Services. We're also covering artificial intelligence, and that one does look at C++. We also do have Python that's just been sorted at the moment, and that'll be launching in the next few weeks. We also have cybersecurity, web computing, and then we also look at managing leadership and performance, and that covers organizational culture, leading others, managing relationships. We also have some further courses launching around computer networking and entrepreneurship as well. And as I said, they are all fully funded to Staffordshire-based SMEs. We can offer these on a commercial basis if you don't fall into that category. So again, please do get in touch and I'll give my details at the end. Could you just move me to the next slide, Justin?
Of course, yes, sorry.
In terms of the other projects that we're working on at the moment, we have fully funded support for prototyping and new product development. That's our SAMPID project. Organisations will have the opportunity to use our resources here on site along with academic input on that. We also have funded support for innovation around transport, logistics and mobility. And this one looks at specifically the greener movement of goods and services on an international scale. And again, that has academic support and student support attached to that. We also have incubation and startup hatchery here at our Stoke-on-Trent campus. So if you were looking for a small office, or if you are a startup and are looking to work in a more collaborative environment, we have the facilities to do that. And people that are using our incubation and startup hatchery also have access to the specialist equipment that we have here. And that includes things like a robotic arm and particle analyzers as well. We also offer a wide array of apprenticeships. These are taught at a higher and degree level and include areas around senior leadership, digital and technical solutions, software development. There's also one around networking as well. There's lots of different courses that we do there if you were thinking about doing some training that will fit in around your work. We also have a Unitemps team here on site, and they'll help you with the end-to-end support of recruitment should you be looking to take on a student in terms of work placement or experience or a graduate level opportunity. And in terms of large employers, we do work heavily with Innovate UK, and we can support you with any bids that you wanted to do there and knowledge transfer partnerships as well. Could you just move me on to the last slide, Justin?
No problems.
Thank you. So really hope you've enjoyed what you've heard today. I know I've learned a lot around a subject that I didn't know lots on, so thank you, Justin, for that.
No problem.
If you did want any more information, you can email us at employers@staffs.ac.uk. There's more information around how we support businesses on our website /business-services. We will be sending the link to this webinar around if you would like to view it again or circulate to any of your colleagues. And further details about upcoming webinars can be found on our website as well. And we'll be publishing our next round of webinars shortly on staffs.ac.uk/events.